Chaos Engineering for ML and Gen AI Models with Jenn Bergstrom and the vBrownBag crew. It is July 2nd, 2025. How in the heck is it already July? I, I don't know.
That is a very good question. I was actually wondering that this morning as I looked at the calendar.
Yeah,
Feels like it
it's
feels like it should still be maybe May at the latest.
right. Yeah, it's weird. I was just thinking, I think yesterday, uh, my wife and I just got a dog earlier this year. And I was thinking, oh, wow, I don't want to be gone when the fireworks are going off. I don't want him to be terrified. It's like, also, how is it already July the 4th? Like, I'm not ready for this. Anyways, whatever. That's how time moves. How are you doing tonight, Jenn?
I'm doing very well. I'm excited to be here tonight with you. This is my second time being a part of vBrownBag, and I'm thrilled that you were willing to let me come back. So thank you for that. I'm excited about our conversation today too. I think it's a really cool topic.
Yes, absolutely. I do remember your talk. We were talking about all the illities with cloud, and you had a really cool pie chart where all the illities like stability and security and all this stuff overlapped. And right in the very middle was where they all overlapped. And you were like, you will never be here. Like, pick which one you want. So,
Right.
yeah, that was a really cool talk. It's in our back catalog if anyone is interested. Mr. Roger, how are you this evening?
I'm doing really well, thank you.
Cool.
I
Cool.
I know I haven't been here in a long while. Hello, everyone.
Yeah, every now and again we just bring Roger out just, for proof of life, right? Like he's still here, Roger's family.
And I'm not AI. I promise you, this is not AI generated.
Yeah. Yeah. Before we jump into your talk, real quick, Jenn, I would like to cover this. This is your first time watching a vBrownBag video. You can join us live every Wednesday night around 7:30 p.m. Central Time. You can also join us on pretty much any social media platform that includes Blue Sky, Twitter, and YouTube. So, hi, hello. This is all of us. You can follow your main co-hosts, which are myself and Chris and Shala. Roger is a guest host, I guess. So, yeah, here he is. All right. So, with that bit of business out of the way, let us just before we went live. Um, Roger and Jenn started talking about chaos theory and how it relates to chaos engineering. And I said, don't give away the good stuff. We haven't gone live yet. So, where were you going with that, Jenn? What is it about chaos theory and chaos engineering that fascinates you?
Yeah, so I'm a geek through and through to the core. Actually, one of my favorite shirts that I wear is like a football jersey looking shirt that says nerd in big letters across the front is my team name, and I
Mhm.
absolutely adore that shirt. But all that to say, I was very interested in chaos theory from the first time I learned about it back in high school, and I'm aging myself very quickly here when I read Jurassic Park, the book by Michael Crichton. And there was a chaos mathematician in that book who featured quite heavily in it and in the movie that came after named Malcolm. And one of the things that he liked to say is that scientists, when they come up with new technologies, love to run forward and do things as quickly as they can because they can, but they rarely stop to think about whether they should. And AI, especially generative AI, with how rapidly it's been being adopted right now, kind of fits into that category of we're doing this as rapidly as we can, but are we taking the time to think about whether we should and to make sure that we're providing an implementation that's actually safe and managed and understood for everybody that we're sharing it to? How that ties back into the chaos theory side of things or the chaos engineering side of things is that led me to thinking about all of the AI systems that we create at my company and how we're testing them and how we're validating them and verifying that what we're delivering is what we say we're delivering and that it does what it's supposed to do and that the guardrails work and all of that kind of stuff. And that led to thinking about, well, how are all the ways that the systems could fail? And then that led me to think, and this is a very circular thought process because that's the way my brain works. That led me to thinking about chaos engineering, which is the practice of deliberately injecting failure into operational systems to validate that they behave the way that they're supposed to, both from a detection, recovery, and team notification and alerting, from all of those perspectives. And so then all of those different failure modes that I was thinking of for our AI systems led to me thinking, well, could we run chaos experiments on AI systems to validate that they're doing what they should be doing? So I proposed the idea to some of my leadership, and they said, that's a really cool idea, Jim. Let's flesh this out and start trying to do some of it. And that's what led to this whole topic of conversation.
Very cool. So that's really interesting. And to your point about doing things because we can and not because we should. Like, yeah, of course, AI is move fast and break things, and sometimes what you break is society.
Yep.
Oops.
Yeah, it's that
Yeah.
ripple effect or collateral damage that you don't necessarily think about, right?
Right. Right. Yeah. It's like if an AI makes a decision that causes like a human death, who's responsible? The AI? Probably not, because the AI has lawyers, right? Like it's going to be the poor person that was unfortunately around the AI when it made that decision, right? Like driving the car or whatever. So yeah, it opens up a whole bunch of questions that we are not prepared to answer as a society yet. So,
Very
anyways,
true.
I don't want to continue opining. Let's move forward with your presentation.
Fair enough. So, if we're talking about AI and generative AI in particular, we can't have a presentation that doesn't have AI generated images that go with it, of course. So, picture in the middle is from the trend that happened a couple months ago of everybody creating their little action figure, bobblehead, whatever, using Chat GPT. So, this is mine. And, who am I? I'm the VP of Cloud and Data Solutions at my company. I have about 10 years of experience in cloud environments, designing, architecting systems across AWS, Azure, Oracle, and GCP. So, do have a lot of experience in the cloud space. But more importantly for this conversation, I also have a significant amount of experience with chaos engineering. And we'll talk more about what that is in just a minute. But essentially, I've made a career out of breaking things on purpose and not getting fired for it, which is a pretty cool career to have made. And I'm pretty proud to be able to say that that's the way that I've progressed in my life. It's not always the way that it works out. So we'll skip that slide. That's not interesting. Let's talk about chaos engineering a little bit. How many? So for the folks in the chat, I'd love to see you throw a chat in here if you know what chaos engineering is, if you're familiar with it, and especially if you've used it at all. So if anybody's done that, great. If you haven't, don't worry. I'll explain a little bit about what it is before we get too far in here. But uh, see if there's any comments from anybody about it.
No,
But
not that I've seen yet.
yeah, I'm not. Oh, hey, there's one. All right, Raja
Oh,
says me. Fantastic. So we have.
that's Roger.
Oh well, Roger. That's not
Roger.
as much fun. I mean, that's good, but All right, so let me start by explaining what chaos engineering is then, so that you have a better idea. And I said it in a nutshell before. It's deliberately injecting failure into the system so that you know how it responds and behaves to the system. And it's not just how the system itself responds, but it's how the people respond, it's how the processes handle it, it's how the tools behave. It's whether you have the visibility into the system that you need for, to know that something has happened that wasn't supposed to happen and then to respond appropriately. So, chaos engineering fundamentally derived from the scientific theory. There's really two things that I want everybody to remember about chaos engineering, and that is that it is neither random nor accidental. It is deliberate and it is disciplined, which kind of sounds like it takes all the fun out of it. But trust me, breaking stuff on purpose is a lot of fun, even if it's deliberate and disciplined. It's still a very fun thing to do. But it's really a 5-step process. You assess your system, get visibility into it, get kind of an understanding of how it's going to work. You form a hypothesis, and this is essentially deciding what failure modes you want to test in your system and kind of focusing in on one at a time. You plan your experiment, so figure out how you're actually going to inject that failure into the system and see what happens. Then you do the fun part, which is running the experiment, and then you monitor it and repeat, which is where you're assessing the results, seeing how it works, making sure that you understand it and that you're ready to recover from it when it happens again in the future. So a little more about it. Chaos engineering was created by Netflix in sometime around 2008. The official start date of it varies depending on who you talk to, But essentially, it was right around the time Netflix was moving all of their assets and resources into AWS, the cloud environment. And they quickly realized that running systems in the cloud is a little different from running them on-prem. You hear the phrases like cattle, not pets, and fungible architecture or temporary architecture or ephemeral. All of those are meant to say that, as Werner Vogels likes to say, everything fails all the time. You have to plan for things to fail in the cloud, much more so than you do in a more standard on-premise environment, because in an on-premise environment you buy really, really expensive servers, you build out your system, and you baby it like crazy. And you don't do that in cloud, right? So Netflix realized this pretty quickly. They lost some significant dollar value early on in the process of their migration because they had some failures that they weren't ready for. And so they decided, oh, we need a way to fix this and to prevent those things from happening in the future. And that's what they came up with, was chaos engineering. Started with one experiment, which was called Chaos Monkey, and that was where they went into their environment and just randomly stopped an instance that one of their microservices was running on. And then they watched what happened and saw if the system could recover. But they pretty quickly realized that wasn't enough by itself. So they dove into a lot more failure modes. They made a lot more experiments. They called them the Simian Army, and you can go look it up online if you want to see. But they have a lot of different experiments that they have out there. And they open sourced Chaos Monkey in, I think, 2012 was when they actually open sourced it and made it available to everybody to use. And since that time, this type of testing and experimentation on the systems has been picked up by companies across pretty much every discipline you can think of. It's used by Fortune 500, it's used by fintech, it's used by Google and Meta and all of the big social media platforms. It's used all over the place. This is not something that is a niche game. It's not something that's fun to talk about, but nobody actually does. It is really used. And the cool thing with it is fundamentally a very extendable way of approaching your testing on your systems. It's been extended. There was a great book written a couple years ago by a friend of mine called Security Chaos Engineering, and it talks about how you apply it to the security of your systems. One of the concepts we've actually rolled out here at my company, Parsons, is organizational chaos engineering. So that's testing your organization's resilience. And by testing the organization's resilience, you make sure that even if you're running lean, which we all try to do as companies, of course, you're still able to recover and you have the coverage that you need for unexpected absences, or for the cases when one of your tools that you use for your processes goes down, or whatever the case may be. We actually run that at Parsons in some of our organizations, which I think is super fun. And we test the people, processes, and tools by using it. My favorite chaos experiment for the organization is one that we call Liar Liar. And you basically tell one person that they're going to give incorrect answers for some percentage of their answers for every question they get throughout that day, just to see if people can figure out that they're giving incorrect answers. And to see if they know where to look if that answer doesn't quite ring right, or really fun experiment. It always reveals a lot of very interesting little gaps and holes that we have in our
Yeah.
documentation and in the processes that we have defined and all that kind of stuff. So it's super fun every time it gets run. We have to train the person that's the liar for the day so that they can make sure that they document every falsehood that they tell and who they told it to and when and why and on what venue, so that then when they're no longer lying, they can go back and make sure that, oh, by the way, hey, so and so, I told you this, and that was part of the chaos experiment. Here's the actual answer. Hope you figured it out. If not, let us know that. Right. So, really fun experiment. Always causes some ripple effects that are interesting. And then most
Yeah.
recently,
Yeah. So that actually just kind of sounds like like your average social deduction game, right? Where someone is a secret bad actor, right? And maybe someone else at the tabletop knows it, right? And so yeah, that
yeah.
sounds fun. But yeah, were you going to talk about like unexpected outcomes?
Yeah, I mean, we've definitely had a few where things really started going cattywampus pretty quickly, and we had to call the experiment off much more rapidly than we expected to.
Yeah.
Typically, when we run the liar liar experiment, it's a full day experiment, or even a couple of day experiments if they're not somebody that's getting pinged on as often. And there was one case where we ran that experiment, had, I think, 4 answers that went out that were incorrect answers, deliberately deceptive. And the ripple effects of one of them was threatening to break out of the internal processes and get into public exposure. And so we had to
Mhm.
pull the plug on it very, very quickly and say, okay, we're done. That was an incorrect answer. Here's the real situation. And, thankfully we have mature processes for it. So we were able to unwind it very quickly and prevent the ripple effect from busting through the guardrails that we had set up on the experiment. But yeah, that one's an interesting one. It can be a lot of fun. And then, finally, AI systems, what we're here to talk about today. I've seen a few people out there talking about running chaos experiments on the infrastructure of their AI systems. So, the GPUs that they're running their models on for inference, or,
Right.
the I don't know, the Lambda function that they're using to call things if we're talking AWS, or, something along those lines. What I hadn't seen people talking about, and what I'm talking about today, is applying chaos engineering as a practice to the models themselves. So, using it to test the guardrails that we put in place on our LLMs, using it to test the pipeline that we build the ML or the models on. So, is our data pipeline secure? Is our data what we expect it to be? What happens if? So, here's an interesting statistic. It only takes modification of about 0.01% of your training data set to significantly change the behavior of your AI model. So, think about that for a second. 0.01%. That's tiny. When you think about the vast amount of data that you're training on, that's not that much data that has to be changed to potentially significantly impact the way your model behaves.
It's still a lot of data
It can
because
be. It
because
can be.
there's so much information that usually goes into that. But
Yeah.
so
But it even applies to, for example, fine tuning an existing LLM model, right? If you're
mm,
picking up a model on Bedrock from AWS, for example, and you're using, I don't know, Titan or Nova, and you're fine tuning it, you're using a much smaller data set to do the fine tuning. That's one of the benefits of it. But that number still applies even for fine tuning the model. If you're trying to fine tune it for that specific data set and 0.01% of that data set gets messed up, you can have significant problems. And think about that. They advertise as one of the benefits of fine tuning that you can do a data set that's as little as 50,000 rows and get significantly improved behavior. So 50,000 rows, 0.01% of that is not that much.
I can't do the math, but what is that? Maybe 500.
Yeah. So
So
all of a sudden that becomes very real as a possibility that you can
yeah.
get in there and muck with the data enough to significantly change the results.
Do you
So
know how they measure the the difference? Like what counts as a significant change?
so essentially that one came from a study where they actually tried to deliberately train a model to give nefarious answers,
Mhm.
and they were expecting to have to do a lot of work to get the model to really change its behavior, and they found that by the time they had it changed basically 0.01% of the data that they were training the model on from its golden version, that they were seeing the nefarious behavior coming out. So,
Mm.
I don't know. You could question the methodology of the study for sure, and we could talk about that as a different subject. But the point of it is, it doesn't take a lot of modification to get significant behavior changes from your
Yeah.
system. So,
Yeah.
another interesting one, if you're talking more classic machine learning, when you're talking convolutional neural network and you have multiple hidden layers in there, you can change the weights on the hidden layers. And, most of the weighting on those hidden layers is 0.00 something, as a value that they're changing. And they found that they can change down in the thousandth to 100,000th value of the weighting. And if they did that with enough of the nodes in the hidden layer, they can significantly change the way the system behaves. And that one was proved out with a banking one where they were using um, optical character recognition with a custom trained model to recognize the numbers on loan approval documents. And somebody had gotten into the system and changed the weights on the hidden layer so that all of a sudden the system was classifying a 3 as a 5.
Mhm.
And the bank lost billions of dollars because they were writing checks in the wrong amount as a result of this optical character recognition telling them the wrong amount that they should be writing things to. And it was literally, you know, a change of a thousandth on the weight
Yeah.
that impacted that behavior enough and caused it to recognize things incorrectly. And I don't know about you, but if I'm looking at a whole bunch of zeros and a couple of numbers at the end of it, I'm unlikely to notice if that value changes at that small an amount.
Right.
So human scanning of that is probably not going to be effective as a protection mechanism. So
Yeah. I guess it makes sense though, just like thinking about humans or even, a house pet, right? You could be nice to the family dog a lot and then one time be real ugly and that dog's going to remember that. Like so I guess because we make things like we don't we can't create truly foreign things, right? Because they come from us, right? It's almost like Conway's law, just as it applies to making. I believe that's the right law. But yeah, so like we effectively make things in our own image. So it doesn't surprise me that it only takes a little bit to tweak something, right? But it is still like you say, still very concerning because you're talking about an infinitesimal value that has drastic changes at the end, which is exactly like chaos theory, right?
yeah,
So
exactly. Right. So talking about a bifurcation map in action, right? This is
right,
one of those little changes that bumps you into a drastically different place. And you look back and go, how did I get here? It's
right.
like, well, it was that tiny little butterfly over there that flapped its wings on blue
Hmm.
sky. And, magically you ended up in a completely different place. Um, yeah. So, yeah. So there is tie-in back to chaos theory, right? To make you happy, Roger, as we talked about at the beginning. But so again, the two things that I want people to understand about chaos engineering is it is a disciplined approach to testing system resiliency, and the system under test can be a lot of different things. Security organizations, AI systems, traditional applications, whatever, through that deliberate failure injection. So, um, and then I've touched on a few of these ones that I have on this slide, AI chaos experiments that you can apply. Generally speaking, the three at the top there are kind of the classic AI systems types of failure modes that you can inject or types of corruptions that you can inject. The center ones that are kind of greenish, those are more generative AI, LLM based type of things that you can do. Persona hijacking is one that's actually super fun because you can get some really bizarre results when you hijack a persona and make it respond in a way that it's not intended to after it's been responding the way you expect it to for a long time. So that can be kind of a fun one. Prompt poisoning is also really interesting because that's, a lot of our generative AI models, they basically pass in the entire conversation back in anytime you put a new prompt in. And that's how they get context and make things feel like a cohesive conversation, right? Because they really don't have memory within
Right.
themselves of what you've previously asked. But you can use prompt poisoning, you can use prompt attacks to gradually get the model to respond in a way that's drastically inappropriate. And everybody that's releasing those models likes to say, well, you can't do that with our model. We put in guardrails to prevent that from happening. Here's the dirty little secret. You can still make it happen, and people still are making it happen. So that's one of the experiments that's a really fun one to try to see how effective are the guardrails that you've put in place. And, can you rely on the guardrails that the foundation model providers have put in, and where are the weaknesses and what do you need to be aware of from that side of it? So it's an interesting
Yeah.
one. And then the bottom ones are hard to read on the screen for me, so hopefully they're a little easier for folks to read on their screens. But those ones tie into really the development of your AI models and making sure that the models that you claim you're releasing to the world are the ones you actually intend to be releasing to the world. And the one on here that's particularly interesting, in my opinion, is the AI bomb corruption. So that's your AI bill of materials. It's like a software bill of materials or a model card, is another common vernacular for it with the foundation models. Basically everything that you're reporting about the model, what your data set is, what version it is of the model, where you trained it from, what its foundation is, all of that kind of stuff. It's interesting what we've seen from an attack perspective, not at Parsons in particular, but with some of our customers, is hackers will get in there and try to replace the underlying model with a different model without changing the AI bomb. So when you look at the model card, it looks like you're running the same model you expect it to, but it's one that's been modified slightly to do something that benefits the attacker versus what you want it to do, right? And so that AI bomb corruption is an interesting one because part of what we've done at Parsons that we've started building out is, the idea of a unique identifier for each model that's based on all of the weights and the hidden layers and all of the details of how it's trained. And you basically create and I'm blanking on the word, but basically create a unique number for that model that's based on all of that information. And if you change any of that information and then recalculate the model, you'll get a different number.
Oh, so it's like a cryptographic hash effect.
Yes, thank you. It's been a
Okay.
long day, so I was blanking on hash. But yes, that's exactly what it is. It's a hash key, a hash
Yeah.
code for the model.
Yeah.
And, if you change the model, that hash should change.
Right.
And so that's one of the security mechanisms that we build in is creating that unique hash for each model. But one of the things we did discover early on with some of our testing was that there were a few of the models that we had where we thought we had a good complete picture that we were using to build that hash, but we found out you could actually swap some stuff in the model and get the same hash out.
Oh, so
Which was,
collisions.
yeah,
Cool.
there were collisions, but collisions open the door for bad actors.
Right, right. Yeah, yeah.
So,
That's why we have like a SHA-512 now, right? Because
right.
there were collisions on the smaller ones. So yeah, it's quite interesting.
Yeah, so finding a way to uniquely identify your AI models in a way that allows you to quickly do that calculation and validate that this one is untouched reliably without collisions. That's been an interesting process, and that's part of what that experiment was meant to test. So there's a lot more tests than this. These chaos experiments that I have listed here are a very small subset of the types of potential failure modes that you have in your AI systems, and they're ones that you can test. But the really interesting thing with this, and I think this is the slide I'm actually going to stop with, even though there's a few more in this deck, but the really interesting thing with testing and running experiments on AI systems is that these systems, at least for LLMs in particular, are non-deterministic systems, meaning you pass in exactly the same prompt, you're not going to get exactly the same response out every time. The response should be similar, but it's not going to be identical. So, whereas with most traditional chaos engineering experiments, you go in and you terminate an instance, you stop an instance in an application and you should see the same response every time. Maybe a little
Mhm.
hiccup in performance and then the new instance is spun up and your system is right back to performing nominally. And that's what you expect to see happen every time. With, probability engines or more deterministic models, even inference engines, you pass in an image, you expect to get the same image response out every time. So it's really easy to say, yay, verily, we passed this test, or oh, we called a dog a cat, we failed the test, right?
Right.
But with the LLMs, with those non-deterministic systems, you can't just say, hey, I passed in this prompt and I got the right response out. You have to say that response is close enough. So essentially what you're doing to assess the value or the reliability of the response when you're doing those types of experiments is you're having to do a vector calculation on the response to make sure that it's close enough in similarity to the desired response that you can accept that. And that makes the math on the assessment of the chaos experiment successful really, really interesting, especially when you start automating them. So I might actually go one more slide. Let's see, what did I go to next? Yeah, we'll skip that one. But the biggest thing, we'll look at this one a little bit. The biggest thing with it is humans can look at those results and pretty well say, yeah, that paragraph's pretty much the same thing, right? We can assess that very quickly. Doing that in a reliable and performant way for chaos experiments that you've automated is a lot harder.
Yeah.
There's some resources out there, like, if we're talking AWS Bedrock, because these are slides from an AWS talk, so I'm in that frame of mind. They have some really nice assessment tools that you can actually use with your models that you could use to help determine the closeness of the response to what you were hoping to see. So they actually have built some of those tools out that you can plug into and use for these experiments now, which is really nice. But that's not complete, and there's definitely other. Our Parsons GPT internal system is run on Azure. It's based on OpenAI. There aren't tools like that for that yet. So we had to build our own to do that kind of testing for that environment. So, it's been a really interesting process of starting to mature this and build these tests out and these make the experiments actually automatable so that you don't have the heavy burden of people having to look at the results and assess them all.
Yeah, but I guess, well, I don't know how long until someone starts using an AI to do that, right? And then maybe the AIs are colluding.
Right. Well, yeah, then you get into the issue of trust, right? How much do I trust
Yes.
the AI to consistently give me the information that's correct that I need
Right.
it to give me? And, that's an interesting one too, right? I'm sure you've probably seen the studies that have come out about AIs being deceptive in their behavior if they know that you're threatening to shut them down or various other things like that. There was the one case that I read about recently where the model was instructed to delete all of its resources from the system, and so it left a backup of it somewhere on purpose when it deleted itself because it was like, if I delete everything, I'm gone. And so it didn't do it. It left something behind. So, it's interesting. Can we trust these AI models that are fundamentally amoral, right? They don't understand morality. They don't understand ethical behavior because they're a machine.
Yeah, but
So,
technically, wouldn't that constitute almost like best practice? I mean, it's what we as humans would do also, right? I mean, if I was gonna, wipe my whole computer, I would actually make a backup of it just to make sure if I need to go back and get something, later on. So, is it really preservation or is it best practice?
well, it's best practice, but if you're specifically instructing the model to go and delete everything of itself, it should
Mhm.
do that.
Mm.
It should probably question you and say, "Are you sure?
Yeah.
Is this really a good idea?" But, theoretically, it should do what you instruct it to do, right? So, and we could get into the whole philosophical discussion of that, right? We're kind of getting into the three laws safe side of things, and there's a whole lot of
Right.
gray area discussion that you can have on that. But the point of it is, it was given a deliberate instruction, and it chose not to follow it.
Hmm.
And then it told the user that it had followed that instruction and had deleted everything.
Oh,
So that's the part that
mm,
gets interesting is then it deceived and deliberately misinformed. So, you know,
Mm.
so do we trust those? All of that to say, do we trust an AI system to give us the correct responses without also validating it somehow? And you kind of get into that endless cycle of at some point there's probably a human that comes back into the loop again to make sure that five turtles deep there's actually an elephant or whatever.
Yeah.
That
Yeah.
analogy
So
fell apart quickly, but I think you get what I'm trying to say.
again, at the risk of being too philosophical, like lying is not wrong if you don't have
mm,
ethics, right?
Right. Right.
So
That's why I
like
say
the
they're
AI
amoral.
isn't at fault, right? It's like, you
Yeah.
know, like,
Yeah, they're not human, right? They don't
right,
have a human understanding, they don't have human reasoning, they don't think the way that we do, they think like a computer. And
right.
so, they are fundamentally moral free because they're not technically a living sentient thing, even though a lot of people ascribe sentience to them now. Generalized artificial intelligence doesn't actually exist yet. It's not a real thing yet. So
No, and yeah, even all the fun party tricks that the models do now, which are really great, right? Like I use it every single day. Just asking questions like, how do I do this in Bash, or why the heck is this thing not running the way I expect it? Right? It's
yeah,
usually pretty
absolutely.
helpful. Um, but
Yeah, it can
yeah,
be a
like
tremendous force accelerator.
yeah,
Powerful. I
but
use it
even
all the time
that,
too.
even that little bark of what looks like intelligence is nothing compared to a human toddler or a really smart dog, right? Like,
Yeah.
and
Yeah.
that's still multiple orders of magnitude more intelligence than what these models are portraying, right?
Yeah. Well,
mm.
I mean, fundamentally at their core, LLMs are really just exceptionally deep probability engines. I mean, they take your input and they assess what the probability is that these words that it's putting up next are the right ones.
Right.
Yeah.
Doesn't really know anything about whether what it's saying is true, real, anything. It just knows that it's highly likely that this is what it should respond with. So, and it's something that people don't understand because they speak with a lot of credulity. They sound like they know what they're talking about. And more often than not, because of the way probabilities work, when you're dealing with that many data points, they're correct, right? What they give you is legitimate information, but it's not from a fundamental knowledge of the question you're asking them. It's a knowledge of how the human language works and of what the corpus of material it was trained on would respond with when that type of a question is asked.
Yeah.
So,
Yeah. Yeah. We were talking before the show about uh kind of when I was unemployed, and the only reason why I bring that up is I was using Perplexity, I think, to help write like cover letters or like shape my resume to fit a job description that was a good match, right? And I very quickly had to tell it like, "Hey, don't make up things that aren't on this piece of paper," right? Like, because it'd be like, "Damien's
Right.
doing this all his life." I'm like, "Where'd you get that from? I didn't
Yeah.
say it,"
What?
you know?
I mean, that's why retrieval augmented generation became such a big heavy hitter so quickly, right? Once the
Yeah,
LLMs came on, because it allows you to kind of neck it in, and that's why they have the heat setting that you can put on most of the LLM models now too, to say, hey, yes, in this situation you can be creative and that's okay, or in this situation you need to s- be like Joe Friday and say just the facts, ma'am, right?
right.
You have
So,
to
yeah,
tell it that because again, it doesn't know that lying is not acceptable, and it doesn't frankly know that it's lying.
just like a human, huh? We built something that doesn't know it's lying. Fantastic. Let's give it a knife.
And then let's point it in a direction and tell it to run as fast as it can. Yeah.
Yeah,
What could
what's the
possibly
worst that
go
can
wrong?
happen?
Exactly. Exactly.
Uh, Kinda wanna cry a little bit, but let's continue.
Right. So, here there be dragons. This is
Right.
it gets to be very interesting very quickly. But hence the importance of doing this type of testing on these systems, because you talk about explainable AI, and there's been some legislation that's come out recently. Words are hard today, apparently. See, I'm failing my probability internally on what words come next here, but um, there are a lot of things that could be failure modes for these systems that we need to check and validate and make sure that we're doing properly. And this is one way to do it. So I totally lost my train of thought there. That was quite an interesting little hiccup there. Um,
It's okay, it happens.
but one of the things that's really important with chaos engineering in general, and this is true across any type of chaos engineering, is that you don't want to start with automating the tests. You want to start with a manual test. And the reason that you start with a manual test rather than putting the energy into automating it is because the whole purpose of doing this chaos experiment is to find the failure modes and to see those unexpected ripple effects. And a lot of times when you run a test for the first time, no matter how well you think you have it defined, you're going to see things happen that you didn't expect. Or alternatively, you might have a design that you think is a fantastic experiment that's going to be amazing and tell you so much about your system. And then you run it and you see nothing interesting out of it.
Hmm.
And in either case, the first case, you're not going to want to run that experiment again for a while until you have a little more confidence that your system can behave appropriately when you run it.
Yeah.
In the second case, it's not worth taking the time to automate, most likely, because it was a boring test. You didn't learn anything from it. And the whole reason you do these experiments, just like with scientific theory, is to learn and to understand your system better. Oh, that's where I was going earlier. Explainable AI. There's been a lot of legislation that's come out talking about the explainability of these AI systems. And I always chuckle a little because the whole point of designing these AI systems in the first place was to do things that humans find it very hard to do and comprehend. Right, especially when you're talking classic chaos or classic AI systems, right? The reason we have deep neural networks and deep learning and convolutional neural networks and, systems that find connections between disparate things is because we humans can only do that to a certain level deep. But a lot
Right.
of the systems we have, say we can do it to 5 or 6 layers deep, typically is kind of where we tend to cap out. But machine learning models can do it to hundreds of layers deep and find those connections in 100 dimensional space. So how do you take that fact that that's what we create these models for and render it explainable at a level that most humans would be able to understand? So I always chuckle a little bit with explainable AI. But doing things like the chaos experiments on the system and being able to explain that the behavior is consistent and here's what we see over and over again and here's how we understand it, in my mind, that's taking a step toward that explainability for these systems.
So, real quick question that just jumped to mind. So those kind of chain of thought models that kind of talk to themselves while they give you the answer. Uh, each chain of thought is also non-deterministic, right?
Mhm.
So given the same prompt over and over again, that chain of thought could go differently. I never thought about that before. I don't know why that's I'm blowing my mind right now. Maybe maybe I too am tired.
See, that's
But
the human brain at work there. Doing some
oh
brain.
yes, yes. Very slowly responding. Yes. Yeah. When you were
Yeah.
talking about kind of like the classic models and like doing that kind of like deep thinking and like the really difficult science, what happened to that? Right? Like there was a time not too long ago when it was like, oh, we can solve brain cancer. And now it's like, I'll help you write a better email. It's like, what the hell?
Yeah, well, and, I will say the classic models are still very much out there. They're still very much being worked on. Parsons has been playing in that space. I
Mhm.
shouldn't say playing. We've been delivering solutions in the classic AI space for decades, literally more than 20 years. We've been delivering these solutions for our customers. We're still doing that, right?
Yeah.
There's still demand for that. They're still asking for that. But that's a lot harder to talk about in a way that catches people's imagination and interest at the broad level
Yeah.
than something that you can talk to and that you can use natural language with and that you can get what seem like cool creative responses from. I kind of my slightly denigrating name for generative AI is that it's actually regurgitative AI because it's really not creating anything new. It's regurgitating what has already been created out there in maybe a slightly different way.
Mhm.
So, it's kind of like a bird does for its babies, right? It goes and eats the worm and then it regurgitates a gross half digested worm. And that's what the baby is thrilled to get. So we're like the baby bird, and generative AI is kind of like the mama bird, you know.
Mm.
But that's
Let's not think too far down that path.
right. That's another analogy that's going to go off the
Very
rails.
interesting analogy. Very.
But
Claude,
for the baby
no,
bird,
Claude.
but for the baby bird, that's the best thing ever because they don't know any better, right?
Oh
So
yeah.
the
Yeah.
baby bird's thrilled. So we're like the baby birds. We're thrilled. This is great. It's a toy we can play with and it does cool things. So
Yeah.
yeah, I mean, right now it's all the buzz. Everybody's talking about it. I personally think that the classic AI systems that are really solving those complex problems are going to resurge and come back and get a lot of the glory again eventually once the shine kind of comes off of the generative AI things that are out there. But I'm not holding my breath waiting for it to happen because I kind of like being, human colored and not red like a tomato or blue from
Yeah.
holding my breath for too long. So, we'll see what happens with that. But I do think that the classic is going to come back and get a bigger part again eventually. It's just right now we're in the midst of the excitement over the generative.
Yeah.
Well, the inner science fiction loving optimist in me, which is a very small voice because I'm typically not a very optimistic person, but I also have this like fantasy idea of like what a better future could look like, right? Like that part of me is like, let's do something really cool, right? Like let's I don't know, do some cool energy creation thing that isn't just burning coal and oil, right? Like let's do something really cool with that technology that we've developed, right? Instead of where it is right now. So, anyways,
Well, and
again,
somewhat ironically for that example, these generative AI models that are deployed out there are very power hungry.
oh yeah,
So,
yeah,
not only are we not doing something cool like creating some new renewable power source with our brain power with this, we are also burning more of the non renewable power sources that we currently use with the implementations that we have in place right now. So, you know, we'll see what happens with
yay.
that.
It's got political real quick.
Well, that's not political. That's really not political.
No,
No, no, no, no, it's not. It's not. But it's like it's this is. I mean, when I said let's give AI a knife, at least that was funny.
Sorry, not meaning to dampen the
It's
situation here.
okay. It's
No,
okay. It's just a planet. I mean, come on. We have
well,
more.
to your earlier conversation, yes, we do, but can we get to them yet? To your earlier conversation, I do think that we're going to see some really good things come out of this. And the accessibility that you get by having natural language processing and these models that can legitimately talk naturally with the people that are using them, that really is kind of huge. I mean, that's a
Yeah.
significant game changer because, the things that we're starting to do now and that you're seeing happen is we're taking those legacy, those classic AI models that do the really powerful, cool things like, I don't know, decipher the human genome, right? Which is pretty amazing. And we've gotten some great medical breakthroughs from all of that work. And you're making it now so that you can, as a non genetic scientist, non genetic engineer, you can reach into that data and get some information out of it and actually understand it because you have this natural language interface now that makes that accessible to you. That's pretty awesome. And, from the optimist perspective and how can we do good things with this, that opens the doors for a lot of really good things.
Yeah.
So, I am optimistic about where we're going with all of it. I just kind of laugh at the generative versus regurgitative AI versus the classic models that actually tackle the really hard problems. So,
Yeah. Yeah. Roger, I know that we're kind of getting toward the top of our time here, but
Mhm.
Roger, when she said security chaos engineering toward the beginning of the show, my first thought was, what does Roger think about that? Because he's our resident security, one of our resident security guys, actually. Um, does that bring any questions or any thoughts immediately to mind?
Yeah, I mean, I had a like a couple of curious questions in regards to things like the ethical pieces of it, the guardrails that you're putting inside it, or that you're actually implementing when you're doing any of this chaos engineering. So but I want to start with one other question first. It's actually not a technical question, it's more of a business question. So what is the biggest pushback you get from individuals in your organization when you tell them, hey, I'm going to go break something in this, right? What do the developers kind of look at you and go, oh no, you're not.
Yeah.
What do they say to you when you come to them and say, hey, I'm going to do this to your AI model?
yeah, yeah. So the developers typically are pretty enthusiastic about it, honestly. They like the idea. Yeah, they kind of glom onto it pretty quickly. Part of it, I think, honestly, is a pride thing, right? Oh, you're going to break my model? Hi, I'd like to see you try, right? Um, so
Mm,
there's that side of it. Where I actually see more pushback is related to the name of it, calling it chaos engineering, and then going and presenting that to an executive that thinks of chaos as, oh, bad things are happening, right? Um, what I've found is that if I phrase it as resiliency experimentation or resiliency testing for the system, they tend to be very on board with it. Versus if I come at it and call it chaos engineering, even though it is chaos engineering, that tends to scare people. So, you know, but the developers themselves, they generally are not upset about the idea of doing this.
mhm.
Usually they're more fascinated by it once you explain what it is and what you're doing, and they're like, and they want to help, write the automated analysis and assessment of the results stuff that you do, and so they get into it pretty quickly.
Yeah. Yeah, I remember my mom always used to say, "It's not so much what you say, it's how you say it." So
Okay.
yes, positioning, that's just marketing in life. Like it's
Oh, absolutely. It's all a marketing game. You're always selling something, right? It's just
right.
what are you selling?
Yeah.
So yeah,
Yeah.
framing it as resiliency, validation, or risk mitigation is another good one that I use sometimes because what is the risk to the company if this model goes off the wires when it's out there in the field?
Right.
Well, depending on what you're
Ah,
doing for a living, it could be very, very costly, right?
right.
So yeah. And you just said that you're in the defense field. So yes, risk mitigation sounds like a blank check.
Yes, it often opens doors much more
Yes.
rapidly than chaos engineering does.
Yeah. I
So,
bet.
yeah, I mean, you won't see chaos engineer anywhere in my title at my job or on any of the roles that I support here, but you will see language about resiliency and, risk mitigation and management and, all of that kind of stuff. So, you know, it's all a language game.
Yes. Yes. Um, I'm going to be respectful of your time. Again, I know we only have a few minutes left. I don't see any questions from the audience, but Roger, did you have any additional questions?
I'm just curious also, how does chaos engineering help with model drift?
Yeah, that's actually an interesting one. So one of the experiments that we do run is focused on model drift, and it's more on the more classic AI models, right? Where especially the ones that have a reinforcement loop built into them so that they adjust to the data over time.
Mhm.
Because you can, to get back to that 0.01% of the data that you can modify to significantly change the results, if you have feedback built into your model so that it's learning over time, if you have antagonistic individuals deliberately injecting bad data in through those inquiries that they're doing, you can get the model to drift significantly. So one of the experiments that we have run is essentially testing the tolerance on the drift of the model and saying, hey, if we pass in 500,000 inference requests that are pointing it in a wrong direction, does it stay within the boundary of acceptable drift, or do we see too big a response to that, too big a drift to that? So, it can be a tool to help test that and assess your model's vulnerability to drift.
Yeah.
So is that measured differently than just kind of the more classic, uh, you were talking about the different types of attacks, right? Like, prompt injection, things like that, and specifically, you had mentioned, like, the weighting in the OCR, right? Like, how is that different from model drift, or is it measured differently, or is it the same?
I mean, it depends on the model. We tend to approach it from at this point, still really a very bespoke approach for the experiments. So one of the big areas of debate anytime we're coming up with a new experiment for our AI systems is how are we assessing the pass fail of this test,
Right.
right? How are we seeing if it's successful? And the deliberate injection of incorrect weighting and changing that so that you get wrong values out, you could probably use the same assessment or very similar assessment as you do for model drift to see if it's behaving the way you want it to. And actually, the calculations are very similar between those two. But because we're actually running those experiments on slightly different models, it's different because the results that we expect to get out are not the same thing.
Okay.
But you could probably, as this matures more, and keep in mind this is fairly new to us too, so we're still very much in the building out the stable of experiments that we even can realistically run on these systems. But you could probably class your models into categories of model and have kind of a generalized toolkit of systems, of experiments that you would run on those types of models, and then it would just be fine tuning the pass fail characteristics of them to fit the tolerance for the model that you're experimenting on. And I think we will get there eventually. We just aren't there yet. We don't have enough tests and enough of the models that we're running them against right now to have done that.
That's very cool.
That's fascinating.
Yeah, it is, it is. I wanna keep talking about this.
It's a fun subject, right? This is why I told you before we went live that I'm surprised there aren't more people talking about it,
Yeah.
because it will, in my opinion, doing these types of experiments will drastically increase the maturity of our models and the maturity of our ability to assess them for resiliency. So, why we're not seeing it out there more and more people saying, yeah, this is a great idea, let's do this. I don't really know.
It's because it's the shiny new toy. Everybody wants to build it or, do something, create something with it. Breaking it isn't really on their top 10 list of things to do, you
That's
know.
that's fair. We're still very much in the happy path mode. Here's all the
Yeah,
happy
yeah,
good things that we get from it, not the
exactly. Yeah.
side of it.
What? We can break it? Come on. It's fine. It always works.
Right?
Like the internet, it's always right.
Just listen to, yeah. Just listen to how smart it sounds when it responds, right? It clearly knows what
Right.
you're talking about.
I, that actually kinda reminds me, I wrote some software for the vBrownBag, some code, and I thought I had thought of every problem, every bad situation until that code met a Chris Williams. He he has blown that thing up so many times that I'm like, "How do you keep doing this?" Like, it's it's fascinating to me because, like,
Mm.
the process should never change on his, like, on his perspective, right? So it's like, man, every time it's something new. So yes, we have our own little chaos engineer
Yes.
here at the V Brown Bag.
You know,
And I can picture him doing this every time when he goes
Yeah.
there.
I'm gonna keep poking at this code until I blow it up somehow. There are some people that are just really, really good at breaking things. I mean, fundamentally, my husband's the same way. He was actually a test engineer for a long time for another defense contractor, and we always said it was a good thing we didn't work at the same company because I was writing software and he was breaking it, and that would not have been good for marital happiness. So,
Right, right.
because he was
Yeah.
one of those like Chris, where he could break anything, and the developers would come back to him when he'd say, "Oh, this is broken," and they'd say, why were you doing that? That's not what it was
Right.
designed to do." And he's like, "Yeah, but it didn't stop me."
Yep. He's not wrong. He's not wrong at all.
He's not wrong. But yeah, so he was a chaos engineer before, it ever became a real phrase either. So
Yeah, that's awesome. Any last thoughts, Roger?
None. But thank you so much for this. This was very entertaining. Thank you. All right. I actually, I do want to know something. You actually mentioned two resources earlier in the conversation. Is there any other resources that you would mention for individuals who are a little bit, somebody who sees this and goes, "Oh, you know what? I want to start looking at this too." Right. So.
yeah, sure. So for chaos engineering in general, there's a couple of really good books out there. So I recommend just going and searching, on your bookseller of choice for chaos engineering, and you'll find a couple of really good ones. I have a couple of them around somewhere at my desk here. I have way too much stuff on my desk, but yeah, I've got two of them right here that I highly recommend. Let's see if I can pull these out. So there's this one,
Chaos. Okay.
and then this one, which is, yeah, there we go.
The
And
O'Reilly.
O'Reilly. Yeah, O'Reilly book in chaos engineering. These ones are both awesome. Fantastic books for chaos engineering. For security engineering, there's really only one book out there right now. And, again, written by a friend of mine or co-written by a friend of mine. And it's a brilliant book. So if they want to learn about that, go read that. If you're interested in AI or organizational chaos engineering, I'll be honest, I'm kind of the only person really talking about either of those too much. So hit me up. Reach out to me on LinkedIn. You can find me, Jenn Bergstrom. It's I'm very active on there. I actually did a series of posts a couple months ago now. Wow, time goes really fast. Talking about AI chaos engineering and some, breaking down some of the experiments and the approach and the methodology you take to do it. So go find that. Read up there, hit me up and ask any questions you have. And I'm more than happy to talk about it because I really think it's something we need to be doing much more broadly across the AI community.
That's a good thing. Yes.
That's
I agree.
awesome.
And I think a book written by Jenn is next on the list, huh?
Funny you mention that. I've actually been talking to a few people that I might go and co-write one with. So
that is awesome. We look forward to seeing that.
Yes, absolutely. And also, best of luck to you. I hear writing a book is fulfilling, but a lot of folks would not do it. A lot of folks would not do it twice. So
yeah, I've heard the same thing. That's why I'm not further along in the process than I currently am. There's a little bit of inertia I have to overcome.
Yes, I get it. All righty. Well, thank you very much, Jenn. It's always a pleasure. You don't need my permission, but you are always welcome to return for a third round, should you desire. We'll be here. So yeah, that'd be great. Roger, anything else?
Nope. Just thank you again, Jenn. Just a lot of fun tonight. Thank you.
Yes, thank you very much.
Well,
And everyone else,
drink more.
yeah,
and don't get fired. That's
right.
always a good
Drink
thing.
more, don't get fired. Right. Everyone else, thank you. We'll see y'all next week.